All right, so for this problem, you're trying to determine the period um, for the satellite to orbit around the Earth. Now, the period is the amount of time it takes for the satellite to complete one cycle or one full circumference, and that is 2 pi r over v. I just also want to start with the force of gravity that the satellite feels is going to be the centripetal force that it has. So you'll have the gravitational constant times mass of the satellite times mass of the Earth over the distance between them, which is the radius of the satellite squared. And that's going to equal the mass of the satellite times the velocity of the satellite squared over the radius of the satellite. Now, if we simplify this equation with a little bit of algebra, we'll get v is equal to the square root of gme over the radius of the satellite. And if we go ahead and plug this into here, what we're going to get is the period of the satellite is going to be 2 pi times the radius of the satellite divided by root GME over the radius of the satellite. And what this turns out to is 2 pi times the radius of the satellite to the 3/2 over root GME. And we know that the radius of the satellite is 4.5 times the radius of the Earth. And it doesn't matter, like, you don't need to subtract the radius of the satellite from the radius of the Earth because when you're doing the radius of an orbit, it goes to the center of mass of the Earth, not to the edge of the Earth, okay? So that's a very important thing to distinguish. So if we're going to do this in all terms of all the given variables, we're just going to say 2 pi times 4.5 times the radius of the Earth, all to the 3/2 power, over root g times mass of the Earth. And that will equal your period. So you can go ahead and plug in all of your constants, and you should get an exact answer for the period.